Okay, now some little bitty sort of topics. Logs to other bases. Now everyone knows there are logs base E and logs base 10 and logs base 2. They are actually all closely related. In fact, they all just differ by a constant. For example, if x, we've got x to start with, we take log of it to get y, we have the e function to get back the other way. If we take x and we take a log base a of x to get y, then the a, raising it, an exponential with a as the base is the way we get from y back to x. So if we look here, yeah, y is log base a of x. The other way of saying that is that x equals a to the y. Up here, if y equals log of x, log base e of x, then x equals e to the y. Okay, so how does the log to a general base relate to the ordinary log? So let's assume we've got a log to a general base. Let's suppose we've got log base a of x, which we've got here. Then the alternative way of thinking about that is that x is a to the y. And now I'm going to do something sneaky. I'm going to take ordinary log of both sides. So natural log of both sides. So natural log of x equals natural log of a to the y. And then the y will come down. So log x equals y log a, we get from that. And then y, solving for y, we get that y is equal to the ordinary log divided by log a. So that's what we started with, is log base a of x, and what we're finishing with is the fact that that's exactly equal to log x, the natural log, divided by log a. So in effect, that means that all logs are multiples of each other. What we've basically shown is if y is log to some base of x, that means that y is 1 over log a, which is a constant, times the natural log. Yeah, all logs are just multiples of each other. They're all some constant times the natural log. And if we had logs to two different bases, if we had log base a of x, which we know is that, and log base b of x, which we know is that, with log b on the bottom. Okay, so when it's log base a, we're dividing by log a, natural log of a, and when it's log b of x, it's dividing by natural log of b. What do we know? We know that if I was to take log a here over to the other side and take log b over to the other side, what I'd end up with is log x. So basically, taking log b, we get log x. Taking log a over here, we get log x. They're the same thing, meaning log a times log a of x and log b times log base b of x must be the same thing. And then rearranging that, we get this conversion formula that says that if you've got log base a of x, so log to some base a of x, it's equal to log b divided by log a of log to the base b of x. And for example, in the case where we've got logs base 10, the log base 10 of x is equal to log of 2 divided by log of 10 times the log base 2 of x. This number here is smaller than 1, so it says basically logs base 10 are smaller numbers than logs base 2, which is pretty obvious. So there you go. This conversion formula is quite handy for converting between logs of different bases. And you can get that conversion formula easily through the natural log in the way I just did.